because it's just.
I see. Okay, gotcha.
just
Gotcha.
this speed.
Okay, gotcha. All right.
Okay.
Are we recording? We're good.
So, like I said, if they can help you with, look, a lot of the basic questions that we have with regards to filtering our data or creating a new variable, they're in a good position to also be able to kind of talk that through to you. But it's yours. They are there to help you, but not do it for you. And that's, I'm sure that that's what you expect. In other words, it's not a joint project. It wouldn't be like, I'm gonna put Taylor and Leah together and say, go run and do that project. Or Lee and Yuritsi together and say, it's your project, it's your joint. It's still your project, you run with it. And if you're running into barriers or you're running into coding questions, Brian and myself are always there and using either the office hours on Wednesday or just simply set up something that we can do on a kind of a on the demand schedule kind of thing. So you know, just give us a day in advance, and I think we can look at our schedules and figure out when we can go ahead and schedule a Zoom call with you and go ahead and help you with those problems. Okay, and if you want, you know, work it out with your project buddy to also have them attend, because then they will get that benefit too from talking to Brian and me. Okay. I know that even though we've had 2 weeks, that project update probably is a little squeezed, right? Just because you know, some of you may have met and talked with your mentor, others haven't. And so I think what's critical here is understanding the question, or at least the types of questions you can ask and answer with your data set. And that really involves you talking with your economist, right? Once you get that, the second part of that project update with regards to what's in your data, that's really gonna be, if you can get it in R, that's great. If you can't, that's where, you know, definitely ask us and we can help you. Because sometimes it's just simply the data set's so big you can't get it in because the memory constraints on R are defaulted to a level that will not allow you to be able to load it up. Brian or I can come in and change that and bring it up so that you have plenty of RAM. And you know, there shouldn't be any limitations within R Studio that keeps you from being able to load these data sets. I think most of the data sets that I saw, we have capacity for. Okay.
And you'll know if you're hitting those capacity issues when R starts crashing on you in the middle. Like either it runs and it just never finishes, or it runs and then partway through it starts crashing.
One way that you can notice this and monitor it is when you're in R Studio, in the upper right-hand corner, by your name and everything, there's a dial that says RAM. If that thing is all the way over to 3 o'clock, you know that you're using too much memory. You know, and most of the times I think we can bump that up for you.
Or if your code is still running and that little progress indicator is showing nothing at all, that means something bad's happened, or has crashed, and we need to get you some additional resources.
Yeah. Questions about the project update? Okay, I'm gonna be a re-recording here, a broken record, if you know what I mean. So I may come back to this at the end of class, just simply to double down. No questions on the project update thus far. We're good.
It just says my data's too big, but that's all. Like the file is too large to open.
To read in?
Yeah.
Have you bumped hers up?
Let me get it in there.
You may be able to do that right now.
How big is your file, by the way? You know.
14.8.
14.8 megs, I think. Yeah. It was surprised if you get a 14.8 gig file. Shut that for. Actually,
That's the bank data, right?
Yeah.
which are you getting?
No.
You're uploading? You're
Laura?
uploading.
Santiago was trying to join online. Are you able to pull up the?
Oh, I see.
He's trying to join online, he needs the information.
Yeah. I was gonna say-
So, start a new one.
Here, let me share that with you.
No, yeah,
Can you see that?
Yes.
there you go. Now, no, read it in as a, like we would our data normally. So read, actually do, install packages study first. And then hit enter and do library papers. So when it's done loading, you'll do that. And then you'll read your data in. So just hit enter real quick. To run it when it's done. And then do give it a name like Bankland or something like that, right? All right. Read CSV. Your phone down there. That should know it.
And were you able to download the week 4 R script? Okay. Everyone okay if we get rolling then? You good? Good. Any questions in general beyond just the project update? Well, I hope you had, I think the that week break came at a good time. And so we should be in a good position to do what we're gonna do today, because there's not a lot here, and this will allow you to kind of really focus on the research project over there. So we've already kind of discussed the projects, and in addition to that, what I wanted to kind of do is talk about kind of how you go about coding in R. I think you've already kind of seen how that goes, because we've done so much in class interactively and kind of seen how I've done it. But we'll just kind of be a little bit more formal about that. Basically, and that's gonna be about commenting and things like that, and just keystrokes, things of that sort. Then we're gonna just talk briefly about debugging and how to go about that, and there'll be a little in-class breakout session for you to kind of put that into practice. And then the RMarkdown. Now you use RMarkdown, and today, hopefully, we'll give you a good example of how that works, what it's for, and in particular, I'm hoping that we get through an example that shows how to make a table in RMarkdown that looks really, really good, that you would then pull into your project updates and your project report at the end, okay? And then that will leave us a little bit of time, but it sounds like most of you have already read in your data, so I think we'll just end up, using that time to either answer any questions or just let you go ahead and get on with your day. So there's a number of things about R scripts that I think all of you are probably having already learned and understood. Simply, as I said, the way that we've interactively done some coding in class. It's really important that you think about things from the way that R takes that code and reads it in. As it says here, it pretty clearly goes from top to bottom. That's the way you write it, right? I mentioned a couple of weeks ago that the way that the R compiler takes each line is not from left to right, but from right to left. It executes everything and then makes the assignment at the end. And that's a little different than how we read. And so you need to be mindful of that as you're kind of going through and trying to code things. You wouldn't comment out something on the left-hand side, you would comment something out on the right-hand side to exclude it from the calculation. And that's because the compiler is reading it from right to left. Another thing to do is, I don't know, I guess I'm okay at this, is think of your code in terms of an outline that you do for an English class. And you go ahead and create that outline, and then you fill it in with, as you write your paper. Here, same thing. Organize your code into an outline kind of form by using comments so that you can quickly move between one section to another section and keep things kind of separated so that you're not having to recompile or rerun a lot of things before just simply to get to the part that you're really working on, okay? And that's just a matter of being, you know, careful and breaking things up into the pieces that are important. And so there's a typical kind of practice that we have with regards to the way that we lay out our code. At the top of the code, you're just basically trying to put an explanation so that you can come back to it and get a pretty good idea of it, if this is even the R script file that does what you want it to do. Okay? And that's why that comment at the very beginning is really important. If you look at my code, I'm going to typically have, you know, a bunch of number signs at the top, and then I'm going to have something like this, and it's going to be the title, and it's just the R file telling me what it is, and then the next line is the purpose of what I'm doing in that code, and I'll have a brief explanation. And then the last thing I do is I come in and I want to know when I did it. I'll put in the date so that it can say, oh yeah, that matches up with when I think I did it. And then I just close it off. And I'll show you a fancier way of doing that closing off and things like that. But for right now, that's the way that I do it. And so I have at the very top a very nice, concise way. If later on, if I'm going to write a subroutine or something that takes inputs, then I would come in and I would put in what those inputs, those arguments were, and then list that out. And then if it has an output, in other words, what it delivers, I would say something along that lines too. I was going to use my other laptop to show you kind of an example of this, but I wasn't able to. So let's just, for the sake of amusement, see if we can. I'm gonna do let's just use Google and see if it gives us example.
Let's see if Brianna's might be on third.
Let's see if this gives us something. Not exactly. This may just be a stab in the dark.
For today's class, what libraries were we posted?
Tidyverse and Stargazer. I'm not finding anything that jumps out. So Let's go back. So this is what I'd have at the top. And then Taylor just asked me a question. What libraries? Why? Because they usually show up at the top. And so the structure of your code would then load your libraries, because everything that's gonna follow is gonna require that. And then one of the things that we haven't done in here very much is create variable for file paths. And so that if you move from one to the, from one computer to the next, you could be able to just simply change the file path and get to the file if you moved it by just simply changing that variable name. Read in your data, and then section your code with comments is really what we're gonna focus on today. So pretty much all of these points we've seen in action a number of times, okay? Later on, we're gonna get to the RMarkdown section. As kind of precursor to that, I think of RMarkdown as being a completely different program, where what you're doing there is just simply taking all of the computing results that you do in R and put it into a format to communicate it to others. And that's like how you would do it in a Word document or something like that. But in this case, we're integrating it into our studio through that RMarkdown so that you can run things in real time in our studio and get it to come out in your output in RMarkdown. And as a result of that, think of your R script as kind of your working area, and the RMarkdown is just how you then, communicate that to your audience. So I think pretty much everyone knows what a code comment is, and how to do that. Here's a simple example of loading a library. We just use the pound sign. Okay. There's one thing that I don't think that we've done is this part. So I don't think I'm sharing. Lauren, is Santiago okay with what we're doing? I'm not sure if I'm sharing that.
I can't see the screen, but I can hear you.
Okay, that's what I wanted. There you go. That better?
Yes, that's better. Thank you.
And Santiago, feel free to speak up when something like that happens. And so I don't know if you have used this command, the Control-Shift-C, but let me just give you a quick example of that. Okay, this has gone to sleep, so let's resume that. And this is a way that you can just simply block out a lot of code that you don't want to run especially when you're debugging or you're just starting to code. So I just loaded in some code here, and let's look at this case, and this is actually one that you're going to be working on today. And suppose that I'm not happy, or I just, I'm running through and I just don't need that calculation that's found in that lines 4 through 6. And so in that particular case, I've got a comment up here that tells me kind of what I wanted to do in the lecture. In the sense it says comment and uncomment a block with Control-Shift-C. And so I can go ahead and comment out a block like that by highlighting it and then just hitting Control-Shift-C, and you can see that then comments everything out. So nice, quick and easy keystroke using this command here, and Mac users can do that interpretation. And you quickly can comment that out. Now, in the same way that I comment it out, I can actually come back in here and get it to come back. Just by the exact same command. Quick and easy keystroke. Okay. What I also wanted to do is I wanted to show you how our studio is very nice in terms of helping you organize and keep track of the different sections that you have in your code. And you can do that by using these dashes. In this case, it says at least 4 trailing dashes. And I can do that quick and easy by using a keystroke. So if I come in here, whoops, sorry, I didn't tell you what I did. So let's suppose that right here, I'm gonna read in my data on line 10. And I've got lots of different data sets that I want, and I want to keep that separate from everything else, just in terms of its structure. So what I'm gonna do is I'm gonna go Control-Shift-R, okay, Control-Shift-R. R, that should be a plus. And what that does is it pulls up this insert section thing, and let's just say read in data. Hit that, bingo. I get this nice comment there without having to do much of anything with the nice dash line. And what makes this unique, let me go ahead and shrink this, is notice down here in the bottom of my editor, it puts in that particular comment for that particular portion of the code. And so if I want to jump around in my code and not have to be looking and scrolling and everything else, all I have to do is touch that, and you can see all of this different stuff that I have in my particular code here. So I can come down to the debugging example, which is here, and if I want to get back to where I was, I just do that by just highlighting, just clicking on it. And so it's a very nice way. And then I can actually use this here to really see the structure of the code. So later on, if I come back, all I need to do is click on that, click here, pull it up, and I can see all of the things that I'm doing in this. And so that's a very useful way of organizing your code and keeping track of it, and then being able to come back to it and know what you did and what it does and whether or not it's going to be the script that you really need for the work that you're trying to do. So it's not in the lecture notes, but it's really something that I found to be advantageous when I code. Okay. Questions about that? All right, so how have you found comments to be important thus far in your coding? Taylor?
It helped me remember what I was working on.
So if you have to step away or something like that, or if it's a couple of days between the time that you worked on it, pretty helpful. Savai?
I would say it helps me stay organized, because sometimes when I was not doing the coding, when I was not doing the commenting in the past, I would get kind of confused on exactly what I was working on.
Leah, do you think you can over-comment?
Yeah, sometimes I'm like 6 lines down, commenting, I'm like, oh, maybe this is not necessary, but yeah, I have to work on that a little bit, I think.
So there's certain times where, look at this one at the bottom. Do you think that's needed? increment counted by 1. What may be helpful is to say what that counter is being used for. You could put in and say iterating over individuals. Counter could be the individual. It could be counter is stepping quarter by quarter so that you have that. So there's times where that would be helpful, but you know, you can read that line and know what it's doing, right? There's nothing there that's hard to understand. But knowing what the counter is actually counting would be helpful. And in that case, you would put a comment around that. Any luck? Why did you think she was on the 3rd floor?
If you know that she left her badge or, you know.
Oh,
Yeah, she would, I
you're
presume
just
she would have,
Brian's hypothesizing,
yes,
so.
exploratory data and life.
Yeah. So a lot of this is pretty, I think you've seen a lot of. How many of you use comments when you debug? How many of you have thought, hey, if I get an error, maybe I can use the comment command to be able to simplify my code to really, in what I think of as divide and conquer, so that you can find the errors that are found in your code. Any of you? Michael knows how to do that. I mean, because a lot of times there may be a lot of arguments in a particular command that aren't really relevant. And so I'll just take, for instance, the filter command. If I've got a filter command that has an if statement, and there's 2 arguments that go into that, I could just simply put a comment there to break one up from the other so that I can make sure that it's going the right way. So let me just give you an example here. So I'm not going to run this, but if I look at line 5, I've got a filter command that's going to grab species that are equal to droids in a homeworld in Tatooine. How do you say that, Brian?
Tatooine. Can I get you to pause real quick? Do you have the Zoom link? Grab just one more time?
Yeah, I got it first.
Okay,
I can send it.
can you send it to Brianna? Go ahead.
Brianna,
Brianna, yeah, she's out sick, so.
okay,
Email just came through like a few minutes ago.
okay.
Yeah.
Sorry, Lauren. You should,
Apologize.
we'll let Brian do that going forward.
Ideally, yes.
And do you need that information again?
No, I have it. I was just missing that.
Thanks. So, and so I could run this and if there was an error, or I just wanted to make sure it was working right in terms of actually getting species that are a droid in the homeworld and Tatooine, then what kind of comment could I use here to simplify this and really break it down so that I can follow whether or not it's doing what I think it's gonna do?
Explaining why you're filtering.
Say that again, Taylor?
Explaining like a comment, explaining like why you're filtering.
Not so much why. So instead of actually it being a comment, it's a way to block something out so that it doesn't run. Does that make sense? I'm using my comment function to not have to delete a bunch of stuff that I know that I'm gonna need later on, but just not have it run. So let me kind of show. So what I would do is if I've got an error here and I don't know where it's happening, I might come in and say, okay, let's just see whether or not I'm getting the right species. And so I put a parenthesis after the droid. And so all I want it to do is look over the data set and grab those observations where the species is a droid. And I don't want to have to delete everything after that. So what I can just simply do is put a comment on that now, right? And so I don't have to delete it all. It's all there, and if this runs right, okay, I could then say, okay, well, that's running right. And so what I could come back and do, if this is running right, I'll come back, put a comment sign there, and then come here and say, all right, well, let's just copy this on the homeworld part. Put it there. And put a filter there. And see whether or not that gets it right. And that way, I'm breaking it up into pieces. And if the previous one ran okay, and this one ran okay, then it's just a matter of making sure that they combine. And then I run it again. And you can see that I'm getting lots of comments here. And my code gets kind of ugly. But I'm not deleting everything, because then I can look at it and say, oh, I've done this, I've done that. And in the end, I'm just gonna come back. And if this line 5 we knew ran well, then I'll just come back and start moving things around again. Where, in this case, I'll just delete everything here. Oops. And bring it back. And because the first part ran, the second part ran, I would expect that if my syntax on this end, combining the two if statements works, then that should work too. And does anyone know why I'm getting this?
Your parentheses.
Say it loud, Taylor.
The parentheses.
Yeah. So I fixed a parenthesis and then I can run it. So, it's a really useful tool to really clean, to make sure your code not only is running right, but also how to really determine, to fix errors and things like that. You'll learn that over time. It's just kind of how a lot of times you'll just sit with someone who's helping you and you'll say, oh, well, that's a nice little trick to be able to see whether or not my code is working the right way and fixing an error by just using the comment sign. Okay. Other kind of good practices, and I think we've covered most everything like that. We've dealt with this with regards to just debugging and things like that. And in the bottom here, you can see how we are just commenting out what our original command was and trying something different. Okay. So Brian, do you have anything to add with regards to how you think of using the comment sign to debug and make sure that your code is doing what it's supposed to do?
That's literally it. You can occasionally put in little checks and stuff in your code. So if you're still getting errors, you're still getting weird values, right? You can put in like a step between that'll sort of check for things you think might be causing the issue, and then examine the results from there to kind of just diagnose it. But a lot of it is just, yeah, as Mark said, using the comments kind of creatively and appropriately. And biggest thing for me, at least, is just not, within reason. I mean, you don't want, if it's just poorly written code that you've commented out, you can go ahead and delete it. But let's say you've got a section of code that just didn't do what you thought it would. Go ahead and keep a hold of that, because
For instance.
Yeah, here you go. Yeah.
Does that look familiar, Brian?
Yeah. Oh yeah, that's me. I wrote that. It's like, I don't know where I'm going. I don't know what this is doing.
And he's referring to that.
Yeah.
Okay. So from a research economist viewpoint, as long as the researcher understands and my co-author understands, we're not, and things are running right, I'm not concerned about aesthetics. And so you'll see a lot of this in my code, because I would rather have this around as a legacy to know what I've done, be it good or bad, than coming in here and deleting it and not having that record. Does that make sense? And so I'll have big sections of commented out code, and it makes my code maybe look a little, well, why didn't you clean it up? You still have all this mess in it. But that mess ensures that I kind of remember why it's a mess. So I don't have a problem with people leaving that in. Now, if I go to production code, if I'm, sending it out to people, I'm, sharing it with the public, yeah, then I'll clean it up. Because I don't, just so that it's easy for them to follow and know what's actually going on, rather than, kind of putting out my dirty laundry for everyone to figure out how tedious the coding was, or how many mistakes or how many things I had to try to finally get to the result I actually had.
Yeah, for me, it's, you'll go down a rabbit hole and you'll do something incredibly clever and it just doesn't really pan out. And then you'll come back to it a couple weeks later and realize, oh, that clever thing that I did that I totally can't remember what I did to get it running, I kind of need that right now, and having those little bits of code or.
And if you've deleted it,
It's gone.
well,
Yeah.
it's in memory, and you've got to search for it. Okay, so let's talk about variable names. So I don't know, there's all sorts of ways to think about how you want to do variable names. Some people are really creative. I'm not. I struggle with figuring out what I should call something. Where I don't struggle is how I keep things organized. So, any of these pens. That's, so one of the things I really like to do is use variable names that tell me not only what's in it, but what it is, in terms of kind of whether or not it's a real number, an integer, a string, a character, or anything like that. And so if I have just simply a single value, like, a counter, like in this previous example, here, how would I do a counter that's found in the bottom of this, okay? Now, these are integers, so what I would do is I would come in and I would say I would shorten it up and use that. The I, because it's an integer, and counter because you know that it's going to iterate over. Okay. And so I'm using this first value, some people, to tell me what's in it in terms of the type. Now, why would I not? Let's look at that code again. Why might I not want to do that and just call it I? This is a hard one, okay? So I don't expect you to get the answer, but here's the logic behind that. Let's go back to my code. If I'm trying to find this, where I changes values, where I gets set to a value or whatever, I would use a search function, right? And so in my code, I would come in here and I would find, right? I'm using the find command, and I would come in here and I would put I. Not only would I get this guy, but I get every single instance of I. Right? And that is an overload. And so I'm going to use a variable name that when I search, I get what I'm after. And so I'm gonna type this in. So I counter, I counter +1. Okay. Now, if I come in and instead of just using I to search over, I put I underscore, it goes to what I'm looking for. It skipped over all the little i's and went straight to the one that I want. So defining a variable with one character is a no-no, because you can't find it. And in this case, I use that underscore because, you know, it just kind of separates it out. I know other people that will use this kind of command. They'll go I and then big, you know, big C or something like that. So if I've got a double, a real value, that's permanent. This working so good. What about if it's a double? What do you think I would, you know, so now it's like a person's salary. What do you think you would, what syntax would you use there? I would use D for double. Things like that, okay? So this would be a double. What if I got a vector? I've got a, you know that it's a number of, you know, observations in the sense of what this filtered data is going to have with regards to the names of those people that have these particular characteristics. Well, I use V, and then, you know, in this case, something along the lines of call it just data, where that V is for, I know it's a vector. And if it's a matrix, then I'm just going to use an M. Ways to keep track of things. And so, I don't know, Brian probably doesn't do this, but I do it. And then last one is S for string. You've got characters, things like that. And that way I know that I'm not going to do operations on it that could create problems, which is kind of what's happening here in this bottom code, is that from what I can gather here is miles per gallon, MPG, is a character, not a number. So that's one way that you can do it. Each of us kind of has our own kind of syntax, things that make things easier. It's just up to you, kind of. But what I would say is, whatever you adopt, stay consistent. Otherwise, you know, it's not serving the purpose that you really want from it. We'll throw Brian, anything that you found to be useful?
Now just, you know, whatever works for you, whether it's camel case or snake case, indifferent, just come up with something and be consistent.
I like underscores.
That is it.
So you understand what he means. It's kind of like I think I erased it, where use an uppercase midway through to distinguish between the two. So,
Although where camel case is nice is if you have a very long variable name, for some reason, just for whatever reason, like it needs to be long. Camel case is be nice, it just reads easier, especially as you're going through a lot of code.
and if anyone has any advice on how to choose variable names, I am all ears. Cause that I've never really,
There's a really good comic out there about professional coders. It's like, what do you think you do? And it's all this kind of really elegant coding design, and what really happens, like foo equals foo plus one or something like that. Like you use a lot of temporary, it's all temporary variables with no meaning behind it.
Lauren?
Yes, so one time I was reading in data and the variable names, it was like, multiple words, but they had like a space, there were no underscores. Is there a way to do that in R, or do you have to do like an underscore, like you can't have space?
Yeah, it's not gonna recognize this space. And that's, and to me, that's kind of old school because, in some ways, that's how file names were recognized within, the file structure. And so if you're going to read in data, things like that, you just couldn't have the space. There's ways to overcome that in a coding sense from a string standpoint, but from a variable context, you run, I don't know, I don't use Python, so does Python allow you to break up your names?
Not sure.
Space?
I mean, there's like some, like, there's like a hack to get around that, where you can put it when, kind of inside the hash quotes, wherever that tilde key is. You can put it inside there, and then some like object types allow you to have like name descriptions underneath with the variable names, and it'll display the name description instead of the actual variable name. But yeah, for the most part, right?
Yeah.
You're going to be in an underscore world.
We talked about this a couple weeks ago where, I would never operate or do changes to my original data. I would copy that over. In this case, this is kind of redundant. They copy over a data set, empty cars into data, then they actually copy data into data temp, and then they do all their calculations and manipulations and things like that to data temp, and then they read it back. I would have just simply done that from the very beginning. This is the one that I'm worried about. This is my original, empty cars is my original data. I would have just said, okay, call it data, and then done everything here. And at the very end, under data, and then copy data back to empty cars. I'm not sure why in the script that we're doing it twice. Just as an extra line, and I don't know what I'm accomplishing there. But we've talked about that, and that's pretty just standard coding protocol. Okay. All right, pipes. So we know that a pipe will take the output from that line and feed it in as the first argument in the next line's function. And so if you have an error, you need to be careful that all the pipes is just one, it's creating a number of lines of code. And kind of going back to the example I showed you earlier, we want to divide and conquer. And so it's important that you break it up into manageable pieces. And then as you run it line by line and add lines as they are okay, you can add back the pipes, but you want to make sure that each line is functioning before you add back the pipe. Sometimes you can get an error that's just got a number of issues because it's a number of lines and it's got a number of errors in it. Trying to figure out which one is which, you can't run it all at the same time and make changes to multiple lines and expect that. You want to get it down to one simple error, fix that error, make sure it's running, then add another line where that may have been the new error, and then see how that then gets done. I would just be honest with you, this is just learning by doing. Debugging is kind of an art form. And seeing someone do it is nice because it's like, oh, I never even thought that I could actually use that command to help me figure out what I'm doing, why the code's wrong. But this is just, yeah, a trial by error, and as you do so, you start to learn and pick up little quick ways to actually debug and things like that. So if you're like me and I get an error message, the first thing I do is Google it. I don't do anything else unless if I've never seen that error message before, I Google it. If I've seen that error message before and I kind of understand it, then I'll start looking into the function name and making sure that it's the proper argument. I think a couple of weeks ago, we had that case where I was using the percentile function and I was putting in 3 different percentiles, and that then returned a matrix, and what I was feeding it into required a vector. And that's where I would have been able to look at the output from the percentile function and notice that it's returning a matrix, and what I was using it for was actually in a vector context. So yeah, the nice thing about RStudio is it tells you when you've got misbalanced parentheses and curly braces and things like that. I'll tell you, my biggest problem is spelling. I can look at the word 3 or 4 times and I think it's the right spelling and it's off. You guys have already saw that with my reading and data and CSV files. So, and that's the thing is I'll go to Brian and Brian will look at your code and my code and goes, oh, you spelled dog wrong. So, and those are nice errors to have. I mean, to be able to fix, but they're make sure you think those through first, because those are the ones that will linger forever and you'll never figure it out because it's a lot easier than you think it is.
Yeah, like the classic examples, you've done a mutate, you've called a certain variable name, and then you've edited the data of that variable name, but you've misspelled it. So now you have 2 columns of data that are kind of the same, but the spelling's a bit differently, and they've got wildly different variables in each. And you got to run your final analysis. It's just way off. It's going to drive you nuts.
Yeah. Warnings. I'm always a little hinky about warnings. I don't like my code. I like my code to run clean. If I get warnings, I kind of think that maybe things aren't right. The code still runs, it produces output, but something's not right. So I would take it seriously if in the end everything runs and you're not changing things and it's giving you the results that you expect. Okay, but if you change anything, I would be really cautious about what the output is under the changed case. So, and there's in your notes, in the slides, you can see kind of nice way to, the types of errors that R produces for you and kind of how to handle it and view it and things like that. In many ways, that's where Google is going to give you something more specific to the particular error that you're experiencing. All right, so this is in your course R script. So I think each of you has that. Do you want to go ahead and go through and as it says, it's the Star Wars data, going to look at the movies, okay? And then there's this case where you're pulling out species and homeworlds of particular type. And then in this case, you're getting the height variable. And if you go in and you look very closely, height is in centimeters, and so dividing it in the normal way, 12 inches, just think of it instead of being centimeters, think about it in terms of inches. Does that make sense? Okay, just let's take the next 10 minutes, see how we do. If you have any questions, just raise your hand. And then we'll review that and then we'll take a little break, okay?
So are we using the debugging example R script that's on Canvas?
Yeah, it should just, this should be verbatim in your script,
Okay.
right? And also read the comments to see, look, in the sense the final data frame should have 2 rows and 15 columns. Kind of telling you what you should get.
Is Star Wars under a certain package?
It should be in Titan first.
Okay. So are we supposed to be like fixing the errors?
If it says there's an error, or in addition to that, is it actually doing what you want it to do?
Okay.
You come to a roadblock, we're here to help. Let's do a little sneak peek.
Oh, here it is.
You convert inches to feet, you multiply by 12.
No, you don't. Great. Tripping.
Oh, you're right. You're right.
Because going from inches to feet. Right.
Mm.
Hmm.
I'm gonna try to figure it out.
Okay.
Okay, I know that I think you guys saw one problem. So did anyone get any errors when they ran it?
Yes.
What was the error?
I had an error for a equal sign on the tattooing part. the
Okay.
homeworld. And I just added an extra equal sign where it says homeworld, because it should be 2 equal signs.
So. On this one,
Yes.
which one?
The homeworld equals tattooing. I put an extra equal sign.
You put an extra? What did you end up having?
Only 2 observations.
Yeah, only 2. Yeah, it was only 2
All
observations.
right, I'm sorry. So did you add an equal sign or delete an equal sign?
I added an equal sign.
Okay, and how did you come to that?
Because I just know from,
Okay, so in that case, this is just the syntax there, right?
mhm.
And the error, the warning, you looked at it and probably, I can't remember what the error was. What did it say?
It said,
Unknown, unexpected
yeah,
equal,
unexpected equal.
and filter.
Unexpected equal. So at least you knew kind of where it was, right? And what it dealt with. And so you had to make it logical, right? That's the logical operator in terms of the equals. And so you did that. Okay, so that was one. What else, Taylor?
The movie films. There wasn't no variable labeled that, so you just had to take the and off of. I am still confused because it lists like all the films 1 through 18 instead of like, like for one film, like like the list would be shorter for the amount of films.
So you're saying that it gave you redundant films, not
Yeah.
just the actual films,
Yeah.
the
Film for each observation.
Right.
Instead
and
of
so
like
you have to, so because Star Wars is what's its observations of?
87. Oh,
There's 87 observations of
main.
characters, right? And not computer characters, but Star Wars characters, right? And so when you pull out this is gonna be the same length. And this is kind of why, for me, I would, if I was using my syntax that I had earlier, this would be V_movies, because I know I'm getting all the movies for each of those characters. And so this is gonna have the same dimension in terms of observations as the original data file, the
So
data frame.
I thought more so it just wanted like a list of the movies that are in Star Wars.
No,
Well,
so
the-
get a list of, and so
Yeah,
what's the command?
that's actually a really good question, right? Like, do you want like a list of all the Star Wars movies that are in the
data set? Or
do you
unique
want
ones?
just a list of, right, like unique movie names that are in the Star Wars kind of universe, right? So that's actually a really good question. And it really depends what you're using it for. And so if you just want like a unique list of names, right? You can use the unique function. So you do unique, and in parentheses, you would put in the Star Wars $ films. And what the unique function does is it takes in a list of strings, and anytime there's a duplicate, it removes all the duplicates. So all you have are just the unique values, which can be very important, especially with your projects, because you're going to have identifiers in there that are not very descriptive, and you're going to want to have some. You probably want to add some descriptions to it, and there may be enough in there that you'll probably want to save it out to an Excel file and type it in and re-import it back, and then merge it with the rest of your with the rest of your data.
See, and as Brian said, I just put in the help function what unique is. It takes, this would be the output from that Star Wars $ films, and it will come back and it says, and as it says, it's a vector or a data frame, and then it's going to return the unique returns of a vector. See, and it says, but with duplicate elements removed. So that would get after what Taylor was thinking. Okay. What other problems did you find?
The transmute in the 11.
What does transmute do?
It said, when I looked it up on the question mark, it said transmute creates a new data frame containing only the specified computations.
How did you arrive at that? How did you say, oh, this is a problem? Because there was no error around it, right? Just ran.
When I ran it, it only gave me like 2 observations, something like that, in like 1 row or
Right.
variable. So
Good.
I looked it up and it said that you could it does the same job as mutate. So I changed it to mutate, and then I changed the height from 11 to 12, and then it gave me 15.
Yeah. So because of the nature of the question, it said, you know, there were 2 rows, but it didn't have all the other information that was found in the original Star Wars. And so knowing what, it kind of goes back to Taylor's question, you know, what is it that you were trying to get out of it? Here it was much more descriptive in saying, this is what you're looking for, not so much here. And so, as Leah said, you know, she only had 1 column, 2 rows. And so it's that transmute, and that was wrong. So it's a valid function, does everything. And that's valid too in terms of an operation. It just doesn't make sense since you're computing fee, right? Good. Any questions, or? That's kind of how you do it. Lauren?
I keep running into the error where, for filter, I have to go back and put like a period comma before species. Like I have to call in the data set. Like at first it says species object not found, but then what happened is in my earlier.
Interesting. Okay, so you want 10 or 15 minutes? Break.
15.
If you hurry, the cafeteria is still open, but it's only open for like a minute. But either way, let's start with 10 and see where we're at. And then we'll come back and we'll get into the RMarkdown stuff.
Are y'all going to the career fair?
I was planning to go.
Why not?
I think
Oh,
I
'cause
am.
you-
Are you riding the bus? Or are you just driving? Yeah, I think I'm just
Is
driving.
it because you're going to law school?
I already have a job,
Mm.
so.
There's no point.
There's no point.
Yeah, I don't know. That's so
Sorry, Brianna. Thank you.
No worries.
Like walking and chewing gum, I'm not really good at it. So this is our markdown cheat sheet, and it's pretty extensive. There's a lot in here. There's probably a little simpler one. Kind of goes through the whole entire process of what it means, you know, of creating an RMarkdown file, what it then produces. But I'm not seeing it. But there should be, oh, here it is. So down here, you can see that just $1 sign is going to be your first header. $2 sign is gives you this, and you can see that as I add more and more dollar signs, the header font size gets smaller and smaller, and so that's a way of kind of working with the text that comes out of your markdown file. So let's go back. So that's what's going on. Here. In this RMarkdown here. Then this is just text. This is actually just going to be text that shows up, and you've probably seen that already in terms of working on your homework the last time. As Brian said a couple weeks ago, these 3 downward sloping apostrophes followed by curly braces, this is the area where our commands are being computed. And so in this particular case, it's going to do an R command, it's pulling in the data cars, and it's running a summary around that. And so we'll run this and we'll see it. But like I said earlier today, do not write your R code from scratch in here. Do it in your script, make sure it runs, make sure it does what you want, make sure that it's doing everything that you need, then you copy and paste what's relevant to that output that you want into the RMarkdown. So if you try to debug in here, it's a nightmare. It doesn't work. It's just not made for that. And so we know that this command is going to run. And then later on, it comes in and it reads in a file called pressure, and it's going to plot an XY plot of the data that's found in pressure and things like that. Okay. So how do I get the output of this? In other words, how do I get the PDF pretty looking document that has that information in it? Well, as you probably already know, you come up to the knit function, and I'm going to go knit to PDF, and it comes back and says, I don't know what this file is. And so you got to define, you got to name it. And so I'm just going to go ahead and say class example PDF, and just leave it at that. No, I don't have to put any extension on it. And so I go ahead and save that. If I come over here to files, so let's just go back real quick. So I put echo equals true. Surprised I didn't see more stuff coming up. But this is what it created. This is the PDF document that it created. Notice it's got the title that was found at the top of my RMarkdown file. So if I wanted to change this to say, hey, I want to just take out the word class, I could come in and delete class, and the knitted document would lose the class. It's got my name because I'm the author, and it's got the date from today because that's, again, because I've got a date here that specifies it. So I could change that just on the fly. And then it's got all that text, and notice that the RMarkdown, which was that double hash, is a header file with that's bold. It's got the text, things like that. And here it says summary cars, and it produces this particular summary table of the information, speed and distance that's found within that car's data file. And then the last one is it plots it. And so it was this command, summary cars, inside this grayed out area that produced this. I got include plots. That's where this is coming from. And then down here, it's going to plot pressure in the gray area. And that's where this graph comes from. So it does give you something to work with from the very beginning to build off of. Okay? But there's a lot more that you can do with it. Let me go back and kind of talk a little bit through what's going on here. Okay? So these grayed out areas are actually what we call R code chunks. And to be able to create an R code chunk, let me just do that at the bottom here. Instead of having to do all these dashes and R's and things like that, all I need to do is Control-Alt-I. So if I go Control-Alt-I, I get that chunk in RMarkdown. The one quick keystroke to get all these. The same thing down there. So it's pretty quick and easy. And so what I suggest is that you just look at, get something like this cheat sheet and it's got everything there and pretty much read through it. It'll give you a pretty good idea of what you can and cannot do in RMarkdown. Somewhere in here, you're gonna see what the comment command is. I'm trying to see if I can find it. Should be. There it is. So right here. You can go less than, exclamation point, dot, dot, whatever you write in between the dash, greater than sign is gonna be commented out. Taylor?
So like when we created the the R Markdown, it creates like a separate file, separate from the one you were working on. So is there a way you can convert a file that's already like
Another R Markdown file?
yeah, but on an existing document?
On an existing R Markdown file?
No, on an existing R script. Can you convert it to R Markdown?
No.
Okay.
So what you're gonna do is you will just work like you have up until this point in your R script, right? Like you did earlier today. Once you got everything debugged on the last little breakout session, and you wanted to show the output, then you, in a formatted way, then you would just simply take the code found there and cut it and paste it and put it in
Your R Markdown.
like this. And we're gonna walk through and make that very explicit.
Okay.
The other way you can do it too is, if you've just got a really massive code block, right? Or you've got a really complicated script to generate the data, you can just save the results with the save command, save it as a .r data file. And then in your R script, or I'm sorry, in your R Markdown file, in that little, the setup preamble, you can load all the libraries that you need up front, right? That you would use to generate all that stuff. And then as your last step, load in the data, and that'll make available your tables, your charts, right? Whatever else you need to display what it is you're trying to do.
Okay.
So I guess
It's a very good way, because you're right, there's the R environment and the R script and what we're doing in our coding. And then there's a separate thing, which is a document, and that's an entirely different environment. There's no way to share data in the program between the two. They're independent. You have to either, as Mark said, copy your code over and paste it into one of the code blocks, or save your results out or your summaries or whatever you're
Yeah,
on.
it might be good for, we'll do kind of a simple one where we'll cut and paste. But next week, why don't we have an example of saving your R script into an R Markdown, and then how you then read that in. Because just like there's structure around our R script and commenting and blocking and things like that, same thing with regards to the R Markdown, is that if I've got say in my project report, I've got a section that's just dealing with data summary. Well, I could do that in an R script, separate, and then just save that to an R Markdown and read it into my actual final project report Markdown file. And then I do that for each of the different sections in my paper. And so we'll build up to that and make it easier to track. I think we've kind of followed all of this, what these code chunks are and why they're important and what they're gonna do. We've already talked about the comments here, using this way to comment. I think this is what's kind of important, and this is gonna be found on that cheat sheet, is that when you run R Markdown, you'll notice that you've got this R, in this case, it's picking up pressure, comma, and then it says echo equals false. Well, what is that echo equal false? And notice this is inside this curly brace, okay, at the very beginning. And before it even calls an R function. Well, what's going on there is inside that curly brace, you can have all of these things being set. And the defaults, meaning that you don't have to touch it, it's already set to that value, is that eval is equal to true, echo is equal to true. Well, echo means that it's going to show you in the actual output file the command that got executed. So in this particular case, echo is equal to true. But you know, if you're writing your report or you're doing a presentation to a bunch of other people that don't want to know what R is or even knows what R, why would I even have that there, right? So if I'm doing it for a professional presentation or you know my final project, I would put echo equals false, and then it would not have that there. It would just simply compute and produce the table. Okay. Now, I could also come back and put in eval equals to false, and in that case, it's not even going to evaluate it. It's just going to simply show what command you've written into that chunk, but it's not going to do any calculation. I could do that just simply to show you what the commands were. Error is set to false. That means that if you run it and it has any errors in it, it's not going to show you any of them, and it's just going to complete, and you have no idea if things are going well or not. So this is a bad default. I'm not quite sure why they did it this way, but we're going to go ahead and always set error is equal to true so that we can see if things are running or not. Okay, and then there's a bunch of other stuff, and the one that's going to be important for today is what results are equal to. And like I said, I'm not a big R markdown person. Markup will show you the code that it generated. So in a table example, that's not what I want. So I'm going to have to change this to as is, and I'll show you how that then plays out when we get to the actual example. And there's a bunch of other things, and these things are things that just make things cleaner, more organized, a little bit, you know, visually appealing. Okay. And those things are, like I said, are set in that curly brace part of each R chunk. So there's a number of ways to use markdown to produce tables. There's 3 examples here. There's a table way, which is found in the slide. There's the V-table way, which is also found here. And then and this is what the output would look like. So let's look at the outputs in these cases. So this would be table. This would be V-table. And this would be Stargazer. Now, I work in a particular formatting language called LaTeX. That's what it looks like. And if I look at the 3 tables, which one looks the most professional? This is kind of like the eye doctor. Good, better, good, better. 1, 2, or 3. 1, 2, 3. 3. It's just if you look at any economic working paper, if you look at any published economic journal, that's pretty stylized. That's what you're going to find, where it gives you the variables And then in this particular case, it's because it's a summary statistic, it's gonna give you particular kind of output. So what I wanted to do for the rest of the class is go through and show what the RMarkdown code would look like to produce this output. And do it in real time so that you kind of understand what that process is like. And this is where it could get a little messy.
Is this like a David Blaine?
I don't know what that reference is.
The magician does those stunts where he like ties himself to a bundle of hot air balloons. He's gotta figure out how to get down before he floats too high.
Okay.
Yeah,
That's news to me.
like a skateboardist.
So let me go to this lecture 4. This is my R script, and I'm gonna shrink this down. And I want you to come down to this bottom point. Okay? Okay, so let's do this. I'm gonna do it this way. I'm gonna create, I already have it. Yeah, no, that's not it. Let's do it this way. Let's go all the way from scratch. Yeah, I can't do it from scratch. Let's do it this way. I've already, you've already loaded your libraries. Did you load your Stargazer library? Okay,
Yes.
make sure all that's ran. And what I want to do is I want to create a summary table of height, mass, and birth year. Okay. So I'm going to pull those variables out of that Star Wars data set. So I've loaded it here and use it down here. And so I've already coded it here, but let's just step through and make sure that everything runs.
You gotta install.
And so let me go ahead and run that, and I want to show you something.
You gotta install.
So, well, first of all, look what I've done. I'm gonna take that Star Wars data,
85.
I'm gonna pipe it into the select function, and I'm only gonna choose those 3 variables for that I'm gonna report the summary table for. Once I select that, that gives me a data frame that I'm then gonna pipe into my Stargazer. Because Stargazer just simply takes a data frame and will produce summary statistics for it. And then there's a lot of bells and whistles around it. And so I want it to give me the median. It always gives me the mean. It always gives me the standard deviation. It always gives me the count. But I don't want the interquartile array, and I don't want headers on it, and that part. Okay, no space. So I'm going to go ahead and run that, and make sure that it runs. And it does. It runs fine. But look at the output that it gives me. Okay? There's no errors, there's no warnings, so everything works. But the output that it gives me is a bunch of syntax that's relevant for LaTeX. And neither, you don't know what it is, I don't know what it is, but it's going to work for me. RMarkdown will take that and format it and understand that and make that very pretty table. So because it ran with no errors, I can then take this R code and map it over into my RMarkdown file. So let me go back to my RMarkdown file that I created earlier. Class example, RMarkdown. And if I look in that RMarkdown file, I notice that there's no libraries being loaded. And because there's no libraries being loaded, I don't have Stargazer there. And so I don't have tidyverse there. So I've gotta do that so that RMarkdown has the functions to be able to run the Stargazer function. Are we okay with that? Does that make sense? So what I'm gonna do is I'm gonna come up here to this particular chunk, and I'm gonna load in my libraries. And I'm also going to add in that my air is equal to true. That's the first thing. Now I'm gonna load my library. And that's tidy. Just like I would if I was back here in my R Markdown file. Okay, same exact way. But now it's, or excuse me, in my R script. And I need Stargazer. And I'm gonna stop there, and I'm gonna knit it to make sure that things are working okay. Same kind of thing. You don't want to just dump everything into it and then run it and have a bunch of errors come up. Write a little bit, see if it works. So let's go ahead and see whether or not this knits. So it's saying that I don't have a tidyverse package.
Got 2 Y's.
Thank you for my spelling syntax. But this is good. I mean, good in the sense of if I did not put the, look, let's do it this way. Let me come back up here and put air is equal to false. Let's do the same thing. It is telling me. So it's not really helping me there. Keep it as true, and then we're gonna come in and fix the syntax. Put in the actual right spelling, go ahead and knit it again. And this time it ran and it produced the figure. Nothing, all I did was put in library, so there's nothing new here. Question, Taylor, are we?
Yeah, for the summary table, is that the code from slide 30?
Say that last part again.
Is that the code from slide 30?
No,
Oh, okay.
from. That, right? That, is that the? No, we haven't done this yet.
Oh,
Let
okay.
me show you. So. So here's my R script again. So all I did was I loaded the libraries that I needed to be able to do things in R Markdown into an R chunk.
Okay.
And that was Stargazer and Tidyverse. So what I did was I took that, I used those, and I put it into this chunk at the very top.
Okay.
That's all I've done. And the summary and the plot are exactly the same as they were before. Now what I want to do is I want to take, oops. This,
Okay.
the Stargazer stuff, which produces the summary table statistics for height, math, and birth year in that Star Wars data set, and get that into Stargazer, and then put that into R Markdown so that it can work for me. So let's go back to my R markdown.
Thank you.
And I'm gonna come down here and let's just do it again. So if I hit return a couple of times, gonna come back here. Here, Taylor. There's one here,
Thank you.
just right there. No sense in you having to stretch it out. And I'm gonna go ahead and use Control Alt I. I get that new chunk and I'm gonna come in here and I'm gonna give it some information. I'm gonna say, I want echo equals true initially, because I want to see what's going on. And I'm gonna use results equals as is.
Can you,
It's command option.
oh, command option, wait.
Command option.
What was that, Shadi?
I was just trying to figure out how to do it on the Mac, because some of our things are different, but we figured it out.
Oh, do the code.
Control Alt I,
It'd be,
Command Alt.
Command option,
Command option.
Did it give it to you?
yes.
So all I'm gonna say is, okay, I'm gonna run an R command. I'm gonna get back the actual command when it's in my R markdown document. And it's actually gonna evaluate it and not just look at it. And this is gonna be needed because the output is kind of unique. Do you have any intuition behind results?
Yeah, so our markdown will automatically format whatever your output is based on the type of document that you're rendering. So if it's an HTML file or a PDF or a Word doc, it'll automatically make those, in particular chart conversions for you, right? When you go ahead and render, you don't have to specify like what this image is or what the graphic is. With the as is option, what that does is it takes whatever the output of that is, and it just runs it as if it were code, if it were just in the regular kind of text section of our document, right?
Yeah.
So instead of
Well, that
displaying
makes a lot of
things-
sense. So,
Yeah.
this may be too much information, but when I come back to this and I run that, let me run it again. You get all this you get all this garbage. And this garbage actually is great in PDF. And so it's gonna see this as actual text inside the PDF, and PDF says, oh, I understand this. I know exactly what this means. And it means I'm gonna make a pretty table. All right, so coming back to my R markdown example, I've got this, right? I've created my chunk. It's gonna have this. And now all I need to do, since I know that code ran and produced output, I'm just gonna copy and paste this into that R chunk. And so I'm going to Control C. I'm just gonna do that again. Control C, move over to my example, come down here, give me a little space, and just paste it. And notice, I never even ran that code in, the R code here. I know this works, because I know it works. I'm trusting that when I paste it in, it will work here too. If it didn't work in the other place, sure not gonna work here. As long as I got my libraries and everything set up like I did in my R script, in my R markdown, this should work. Okay. Let me just go ahead and run this. In other words, let's go ahead and knit this and see what we get. So I'm gonna minimize that. And let's go ahead, knit to PDF. And since I put that R chunk at the bottom of the file, it's gonna be found at the bottom here. And so I get a very nice formatted table here. Now, because I put echo equals true, I get this command. Now, if I'm doing my report, I don't want that there. So I put echo equal false. If I'm doing my homework, I would put it in, right? Because from a homework standpoint, we want to know what code you're using. And it's just not simply that last portion of communicating. We want to make sure you're in that circle doing the analysis and transformation and all that kind of stuff correctly. And so you'd put the echo equals true there. So let's come back. And one other thing that we can do here in this code, and I shouldn't be doing it here, but I'm gonna do it anyway, is there's a command called header. And with header, I can put a nice, oh, excuse me. Actually, I want false for the header. But then I want the title. And the title tells me, you know, kind of what the table is telling me. Summary stats from Star Wars, from the, let's say, data frame. I think we're good there. Now let me go ahead and knit that again and see how things change. Everything worked? Ooh, so something happened, it didn't like it. And that's why I'm getting the error there. So let me shrink that down.
You know, be a great suggestion, Mark. Copy that over to your R script and.
Yeah.
So we're running there, so not debugging in Markdown.
Well, that's why I said I shouldn't be doing it. Let's do it here. Title equals test. So, you know, I'm just testing. I just want to make sure, see how things work, right? So make things quick and easy. That's not the actual thing I'm going to do at the end. So it says unexpected symbol in title test, no space. So I think that would help, right? A comma, breaking out the arguments. Run it again. And I get a good output. So following Brian's suggestion, let's copy and paste this over into my example. And what I'm going to do is paste it in above it, the previous one, and delete this one. And now let's knit it and see whether or not I get what and after. Yes. And as you can see, now it's got a header, table 1. It's got a title, table 1, and I put in that short, brief quote of test. Okay. So that is how you would do it. There's all sorts of things that you could do by playing with these echo eval, but you need this results is equal to as is. Otherwise, it's not. Well, let's go and see what other options we have for, let me go back here and, so if I don't use as is, I could use hold or hide. I don't wanna hide it, we don't want the output to be hidden. But if I go with anything, let's just use hold. Let's see what happens. So if I put hold in here, and I knit it, things aren't gonna come out quite the way that I wanted. I just get the strict output, it doesn't view it as being commands. And so as a result, it just gives me kind of the output that I got from the R script. So that's why I'm saying, at least with Stargazer, I need to put in as is. And that then will work for me. Okay. Questions? There's a lot there. So what we'll do is we'll take this RMarkdown and post it to the Canvas page, because that will then be a very nice template for you to use going forward when you want to do a summary, a table with your summary statistics. And one thing you'll definitely be doing in your on your research project is a summary table of the data that you're doing or working with. Okay. Any questions or anything, Brian, that may make the next week easier?
Not really. Just going back to the our markdown arguments in the code section. When we get to plotting, it's rare that it ever looks right the first time. Things are usually kind of sized really weird. There are options for fig height and fig width. And
Right
that's, yep. So when you output your plots from your data, you can adjust the size that they render on the page, right? In inches, you know, with those arguments. And that's really helpful because often, right, you're just got a huge chart that you're trying to render and it's, you know, blowing up the whole page, or it's not fitting properly, or right, like.
And then, and in many situations, that's just trial and error with those numbers.
Yeah.
There's no rhyme or reason, you just play around with it and see what allows it to look good.
What's also nice about those is that, you know, I know everyone struggled with this, but if you're working in PowerPoint or Word, you're dropping in somebody's plots, then you gotta figure out what's the right size to get them to fit right on the page and that kind of stuff, and they're never the exact same size, and it's just a nightmare to manage. In our markdown, you can just sell that with one argument at the very top with the figure width command, and that will go ahead and just handle everything for you. Everything lines up and it locks properly, and looks real clean.
Yeah. All right. So we'll give you, who needs help with their data? Were you able to get your memory expanded enough to get it on? Yeah.
I got it, yeah.
Okay. So the three of you have your data, it's in R, you're good to go.
Well, I'm still.
You talked to
Naima, I think.
Naima.
I think that's right.
That's right, Lauren. I sometimes call her Naima, but it's Naima. Yeah, she'll be fun. She's a Howard, I mean, she's a Howard grad. So, and she's taken this class when she was at Howard. So she has a really good idea. All right, well, then have a great weekend. I wanted to talk to, well, Lauren, you can hear it again, but I wanted to Michael and Casey and kind of give them some input. And Santiago, if you want to listen too, that would be great too, if you want. I'm just going to talk about kind of the project and the students.
Sounds good.
Okay, thanks, Santiago.
Yeah.
It will be like 5-10 minutes, it won't be long.
Stop board or?
Yeah.
Thank you.